closer look at resistance. If we could see inside a wire in a circuit where a current's flowing, we might see something like what you can see in this image, where we've got blobs like this that are the atoms of the metal that are pretty much fixed in place. All they do is jiggle around a bit, and flowing between them are the electrons that carry the current. Now if you watch the electrons for a minute, you'll see that they don't go straight through, that some of them hit some of the metal atoms and bounce back or are deflected. And this slows down the flow of the electrons. And this slowing down of the electrons we call resistance. The more difficult it is for the electrons to get through, so the more collisions they experience or the more they're deflected, the bigger the resistance is. We can model resistance by imagining it's a bit like friction. We know how friction affects the motion of objects. Friction slows things down, and the more friction there is, the slower things go. So we can think of the electrons experiencing a sort of friction as they try to get past all the metal atoms, and the more friction there is, the slower they go, so the bigger the resistance is.